Hello everyone, welcome to our live stream session tonight. Let me swap the audio here. Yes, it is optimization with an S because I'm British. If you want, I'll change to the Z later, or Z rather. But yes, we're here today and we're doing a live session all about optimization. Now, although we're doing everything about optimization, it doesn't mean that we're going to cover everything in optimization. Optimization is one of those things where there's lots and lots of things you can take onto a board. But I'm going to cover the key main things you should be looking at if you're an indie developer, and especially if you're planning to publish your first game. There's a lot of little things that you need to know about and things to look out for, and things that also answer some questions that I see a lot of people asking a lot of, and seeing a lot of false commentary going around. Yeah, we're going to be going through all that. Thank you for everyone for the well wishes. If you haven't seen any of the social media stuff, it's been a week of hospital visits, as well as launching the trailer for Mimic. My daughter has been very ill for the past couple of weeks and was diagnosed with pneumonia on Wednesday. So my wife was going to come with me to the game show on Thursday, but she had to stay behind and look after Aurora, like my daughter. And then on Friday, my son got ill, and we had them both in hospital all day long. Because my son has like a compromised immune system, so everything's really dangerous with him. So we have to get him checked out, and he had like a chest infection. But they got antibiotics. My daughter's still on IV antibiotics, but she's allowed to go home, which is great. But yeah, it's been a stressful a stressful week. But they are getting better. The fevers have gone. It's just getting them back to being proper now. Yeah, busy week. But as I also mentioned, we launched a trailer for Mimic, and hopefully everyone's here has watched the trailer for Mimic and enjoyed it, and hopefully everyone's wishlisted it. Please do wishlist the game. It really does make a difference. A lot of conversations you have with publishers or investors or things like that, one of the first questions I always ask is, how many wishlists do you have? So please wishlist it, okay? It really, really does help. And that goes true for any indie game, not just mine, but any indie game. Wishlisting does help them get funding and support from publishers, which is weird and always backwards, because you ideally want publisher support to get you bigger wishlists, but they don't want to give you that support unless you've got a big wishlist. It makes no damn sense. But hey, there we go. That's what it is. Okay, so we're going to kind of break this up into certain aspects, okay? Because there are different ways to optimize the engine in your games. And there's a couple of things I want to go through specifically in like their own little section, so we don't get lost in the milieu of it all. So, first we're going to focus on is textures. So, as you can see, you probably are familiar with the texture streaming pool budget warning message. What does that mean? So, before you understand like how to optimize anything, it's a good way to understand it is to actually understand what it actually means. So when it says texture streaming pool, what does that mean? Well, what that means is that when it loads up this level, for example, what it's doing is it's loading textures into memory. And that's like a RAM, basically. And what we call video RAM, VRAM. And what then it does, it streams the texture data over to the game as of and when it needs it. Okay, so it doesn't have to go all the way digging through memory to find it. It's already loaded up. It's just sitting there, ready to be streamed across. And what the stream pool means is that it's the amount of textures that are in there, and their resolution and memory size is now higher than the budget. Now, Unreal Engine by default has a very low budget of 1 gigabyte VRAM. Now, if you were to do any Googling and look around, you'll see that there is most of your budget pools are going to be much bigger. Like, you're looking at 64 gigabytes of VRAM or higher. Yeah, looking very large. So by default, this is going to be very, very low, which is fine because we can get past it really easily. And the way you get past it is by inserting a command. Now, in the editor, that command, you can just type in at the bottom by hitting a little command button. You can't see it because my face is in the way. There you go. Let me just bring that down now. We can get our texture streaming. Let me do that again. Pool size would be the easy way of doing it. Streaming pool size, that one. Okay. And put a space, and you type in what you want it to be. So let's say I want it to be now 2 gigabytes. You put in 2000. Okay. And now you can see I'm only 7.41 megabytes over. Okay. So still not there, but let's go a bit further. So streaming pool size 3000, and you should see it go away. And when you do that, you'll notice that textures are now going to be full quality, not these low res versions. So it's super important that we get that right. But for your actual game, when you're launching your game, it might be a good idea to call that console command right at the start of the game. So in your game instance, for example, you want to insert the console command for that. And the command, I'm just going to do it inside the level blueprint to save time. But I put mine in the game instance. You can just do console command, and you put that console command in. So r.streaming.pool size 3000. Okay, and it will do that and start the game and be all okay. Okay, so it's sort of reserving 3 gigabytes of budget for that, and that will help make that a lot better. But let's get to the actual truth of the problem, because we don't want to set aside a big budget for our texture stream. We want to get it as low as possible. How do we actually do that? So here I've got a pack from the marketplace, and the packs from the marketplace are great, but there's one thing that you must be aware of and must do when you're using them, and that is check your texture sizes. So if I go to tools up top here and go down to audit, then statistics, this brings up this menu here, and then the drop down at top left, you've got a few options. We're going to use texture stats, and this basically shows you a list of all the textures that are being used in your game, in your scene, that you're currently loaded into, and various information about those. So how many actors are using that texture, whether it's virtual or not, whether it's what its dimensions are, how much space is it using on memory. So here you can see current memory is 2,044,424 kilobytes, so just over 2 gigs. And it can sort by just clicking on the top, and it will sort it, and you can see what are your worst offenders, basically. Now, one thing is really useful to be aware of is the texture sizes. So texture sizes, you'll see by default are mostly going to be 4K. I will tell you right now, your game does not need 4K textures. If you think about what your game is actually showing on, you're showing the whole scene on a 4K TV at most, right? Most likely. But most people are not even using 4K. But if you are using 4K monitors, this whole scene isn't using 4K. Like this pillar here is using a small section of it. So therefore, it's wasted, okay? So you want to be very cautious and make sure you're not using the full high-res versions of 4K. So I've often said this to people, and they'll say, like, well, why do they make their textures 4K then? The reason why is because you can always go down in size, you can't go up. So if you go up, you're going to see just a load of like artifacting and weirdness. Not good. So we want to make sure we can only go down. So be aware that when using the audit thing, you use it to find your worst offenders. Now, the very first thing you should look at are your normal maps. And you can see here, T-building normal map. 4 actors are using it. This one's got 114 actors, and this one's got 198 actors. So let's take a look at this. 119 actors are using this normal map, right? And what's really good about this is if I click on this, it takes me to the content browser where the normal map is stored. Now, if I open this up, you see the normal map. There is no need for it to be a 4K texture when it's this lacking of detail. As you can see, this is at 23%. Yeah, if I go to 100%, yeah, there are little details, but you're not going to see them at all. And some normal maps are completely blank. Like this one here, skyscraper. This one's a 4K texture. Look at it. It's nuts. So you want to bring these down. Now, the easiest way to bring them down is, first of all, I would suggest all your normal maps, bring them way down. So the easy way of doing that, into content browser, is go to your content folder, the root of it, and search for the word normal. Chances are they've named them all normal. We're going to select all of them. Right click, asset actions, edit selection property matrix, and wait for that to finish. Yeah, if it's a single color, that's right, Evan. You could just make it just 1 pixel. So Mimic, I've done that. If I've got something that's 1 color, I'll just make it a single, not even a single pixel. I'll go in and edit the actual material and just chuck the color into it. Yeah. That's right, Sean. Yeah, that's right. Yeah, so in here we go into texture, or as a search for it, max. You'll see maximum texture size, and just type in whatever you want. Well, not exactly whatever you want. Make sure it's a power of 2. Now you'll see the power of 2 come up quite a lot. So 1496, for example, 1024, all that stuff. Why do we have power 2? It's to do with memory. So textures can use up memory efficiently if they're in powers of 2. I could go into the maths of it, but I don't want to spend the whole time doing a maths lesson. But essentially, if it's a power of 2, we use something called mipmaps, and the engine will generate mipmaps for you. Now, mipmaps are basically level of detail for textures. So if it's a power of 2, the engine will automatically swap out the textures based on the level of detail. So maximum texture size, make sure it is a power of 2. So in here, we're going to do 10, or for normal maps, we're going to go to 512. Really cut it down. Do that, and let's see what difference that makes. Got to wait for it to do it though, because we're doing quite a lot. Okay. Yep, save those. Hi, Red. Yeah, mipmaps are just LODs. As long as they're power of 2, the engine can downsize them automatically easily. Again, I can go into the maths of it. I don't want to. We're wasting our time doing it. But yeah, there we go. They're all done. So as you can see, the level, oh look, looks exactly the damn same. Yeah, you're not going to notice any damn difference. But if we go back to our thing now and refresh that, remember our current memory was sitting at just over 2 gigabytes. We've now gone down to 1.2 gigabytes. We've shaved almost a whole gigabyte off our VRAM just by doing that. And as you can see, the level looks exactly the damn same. So it's a very easy win. Okay? Strongly recommended. Next, there aren't just normal maps. So if I go to Tools and go to Audit, Statistics again, refresh this, and again we go back to refresh our current memory. Okay, now we've only got one texture in the whole entire thing, which is using 21 megabytes. Yeah, that's only one, but it's been used 6 times, and that's a normal map by the looks of it. Yep, and it didn't catch that one because it's an _n. So let's do that one as well. _n. There we go. I'm just going to go back to my content. We want to filter to textures only. There we are. And we'll just do cyberpunk assets. There we go. So we'll do this one. And we'll just do these ones as well. And we do max texture size 512. I think we have. It may not have been in the next episode. We went nav link proxies, but I think we did do it at some point. Might have been later in the series. Okay, now we're on that one. What are we down to? Not much difference. Yeah, 'cause it was just that one really using it, I think. But anyway, Another one to look at is what you see here, ORM. ORM, what are they? Well, that stands for opacity, roughness, and metallic, I'm assuming. But basically, these are what we call packed textures, and they look like these sort of things. Yeah, and these are much like normal maps. You don't need them to be that detailed. Yeah, these don't need to be 4K. Emissive maps as well, the same thing. So I'm going to go into and search for emissive. We'll turn all emissive ones down. And these are very quick, easy wins for this. And you have to judge it based upon each one. So by default, I'm set to 512, but there may be some exceptions to this. And I'll show you where you might have one exception. And it comes down to, like, how is the texture being viewed in the world? So if we look at our world here, cyberpunk world, these are the neon lights, obviously. Now, these are the signs that I just edited. Now, depending on whether you like the low texture or not, as you can see, as you get close enough to it, it's starting to show its detail loss. But that's because that's way up there. Now, if I'm never going to get close to it, not a problem. If I am going to get close to it, we can just up it. Yeah? You can start seeing the artifacting now. So let's bring on the night one. We can up that. So let's find that one. And this one. Shoestring travel. No. No. Pizza. Where the hell is it? I'll tell you, it would be easier if I just did this. If I go to the folder for this, right click, reference viewer. There you go. So that's it. Oh, that's one I haven't actually changed. It was low to begin with. Okay, fine. That's not my problem, that one. Leave that as it is. But you get my point. If there's one that's going to be really big in the world, by all means up it. You judge it based upon what you're using it for. Okay, but that's just the emissive ones. Let's now do the, what do they use? ORM. Yeah. ORMs, we're going to get normals, aren't we? Crap. I've got to just do it a whole lot again. ORMs are what we call packed textures, and this is another way of optimizing. So hopefully the artists have already done it for you. You don't have to worry about packing them. But if you haven't got them packed, basically it means that the opacity, roughness, metallic, specular, all those sort of things, emissive sometimes, can sometimes be separate textures, which you may not want. And you can get that right down if you bring it into packed textures. And I'll explain why in a second. Let me just edit this one. Compression. Maximum texture size, 512. O was for occlusion. Oh, it might be occlusion. Yeah. It might be occlusion. It may well be. Every artist names them differently. You often, like, I'm surprised I haven't got specular in there. Usually it's specular you get. Usually you get specular, roughness, and metallic. And, like, opacity or occlusion would be something different. Yeah, whatever. They name it all differently. You have to look at what packs you get. Okay, so now we've done that. Let's go back to our audit and see what we're sitting at. Let's refresh that. Okay, we're down to under 1 GB in VRAM. Awesome. So remember, that was sitting at 2.1 gigabytes, I think it was originally. Yeah, same. The level looks exactly the same. Okay, and we've got it way down to using less than 1 gigabyte in texture streaming. Yeah, so really big improvement on our systems, and because it's using less streaming pool sizes, it means it can run on weaker systems, which is what you want. Yeah, perfect. Okay, and lastly is the other textures. So all the diffuse textures. This mostly comes down to what the object is. So if it's something small and rubbish, like this rubbish bag, trash bag, Let's have a look at what textures they're using, if they're using any textures at all. Yep, they're using these textures. So this garbage bag texture, we'll browse that asset, is, see, the artist already knew, this is now a 1K texture already. I'll leave it at that. But something small like that, you probably can get down to get quite low. Same with these texture cables. I think that one's already quite low by the looks of it. But as I say, like when you're zooming around a level like this, you're not usually like this in game. But same with these bottles, I'm assuming they've already got weaker, smaller sized textures. Yeah, 1K texture. And you could even bring those down if you want. But you can always look at what your worst offender is by using the audit tool. So if I was still having like questions about what the hell's causing all these problems, I'd go to current memory, and I can see the ones that are causing the most offense. So you can see these ones are 4K'd still. Now, as I said, most things you don't need to be 4K. So if I go to current dimension like that, select all the ones that are 4K, and we're going to I can't open them up like that. Sorry, I forgot. What you want to do is just go through and change each one. There's no quick way about it, unfortunately. But what you can do, I should have done it the other way around, but never mind. Ideally, I should have started off with those ones first, because I can bring those ones down, and down, and down, and down. But alas, because they haven't got them in folders. Like, you could, I guess I could search for just color, because it looks like they've just called it color and base. Base? Nah, they've all got different names. But if I went base, that's what, a few of them. 2K, 1K, 2K, 4K. You know, you can bring them down. Yeah. What about a competitive game where FPS is more important than visuals? Would 4K not be used very often for textures? Barely at all. Like, 4K textures, as I said, you have to understand, if your monitor's like 4K in resolution, right? If an object is only taking up 10% of that screen, it cannot be fitting 4K textures, 4K pixels in that one bit of item on the screen, yeah? So, no. You're always going to go for FPS and low VRAM, especially if you're doing like multiplayer games, because you want more people playing it as much as possible. So they're less requirements, hardware requirements, the better. So yeah. Hobbies with newbies. Would you recommend optimizing as you go along or towards the end of the project? Always towards the end of the project. There are some things that you can be aware of, like as you're doing it, but for the most part, like what I just did there, I'll do at the end. Because I might change the level about and may use different assets. Okay. So that's textures. How do you package textures? Oh, do you mean like pack them? You have to take them into Photoshop, and if I actually show a packed texture, so this barrel here, they use packed textures, and what they do. The reason why they use, like in this case, occlusion, roughness, and metallic is because these are one channel texture channels. So you just need one channel for it, one value between 0 and 255. And so that means that I can put a different texture in R, G, and B. So you just take all these different textures into Photoshop, assign one to the red channel, one to the green channel, one to the blue channel, and then you output the final result, which looks like this. And as you can see, if I go and I want the occlusion map, that's the occlusion map. If I want the roughness map, that's the roughness map. And if I want the metallic map, there's a metallic map. Yeah. So you can combine those in there for that. And that's how all you do, is you just put that into Photoshop. If you go to channels modes, you can change the channels there. You can Google it, you'll see how you do it. It's not too difficult. Okay. DNF Jeff, have you had experience with media player? It claims to be the only able to source video file from URL. Yeah, I've done that before. I did it before. I made a virtual museum for someone and they had films I wanted to show off. So I made a fake cinema screen, and it was streamed the video files from a server. Yeah, just put URL in. Okay, next up, that's textures. Okay, so lots of work can be done with textures. You will find as well you get some weird textures that you don't need. So if you, example, are using MetaHuman, you probably don't need to worry about the textures for the teeth or the reflection textures for the eyeballs. I just deleted them in my Mimic game because who the hell's going to be staring at the reflections in the eyeballs? Got rid of them. Teeth, I've got them down to like 64, like not even that. Like we've got way down. Okay. So yeah, just review what as of and what you need. Okay. As you saw though, that audit tool that you may have seen anyway, is in the drop down there's other options too. So for example, I can go to primitive stats. Now these are the models you're using. So you can see which models are your worst offenders. And you can see how much memory they're taking up, their counts, how many have been used, how many actors are being used in, how many tries they have. But the thing you want probably the most is the size. So here you can see our biggest offenders are the cyber cars, and that is they're running at 10 megabytes each. As you can see, models are a lot cheaper than textures. Okay, so a lot of people worry about like, is my model too? I mean, it can be too high rendered, too high resolution, but generally speaking, they run a lot cheaper than thing. And you'll see some companies will even just use just a model and no textures, and just use vertex painting, as it's super cheap. But let's go to the cybercar. Okay, there's my cybercar. This is according to it, the most expensive model it has, and even that is not that great, like, of expense, really. So you can get this down as well if you really wanted to. How can you get that down? Well, one thing you can do is do something called LOD syncing. Now, you may be already familiar with LODs. LODs are usually automatically generated for you. So let's actually see if this one has done it automatically. So LODs here, we go down, we see LOD picker. Oh, it hasn't. Problem. Okay, good. We can solve this one then. So in this case, this vehicle has not got an LOD setup. LOD stands for level of detail. Now the way this works is if the object is taking up less space on the screen, it will use less polygons to render. Okay, and we swap it out with different models. Now Unreal Engine can automatically generate this for you, and most of the time it does it quite well. So this LOD you see here is not auto-generated. So all I'm going to do is go down here, see number of LODs, I'm going to change that to 3, and hit apply changes. Now Unreal's going to take a look at that model and generate basically lower resolution versions of it. How to get low video RAM on new project, what we can set our project settings. It's less about what the VRAM you can't really, like, it's more about what your end product is doing to VRAM, not what the start of the product is doing. But anyway, here we go. A number of LEDs is done to 3. And now, if I were to zoom in and out, you shouldn't really notice any difference. But that already is, what's that, 10% of it? So LOD 0, it has 75,000 triangles. At LOD 2, it has 18,000 triangles. So big difference there. Yeah. Now that only kicks in here. Actually, ain't too bad actually. But you can also customize these too. So if you go to your LOD settings over here, I can see, go to LOD 1, looks like that, LOD 2 looks like that. Now you can see, not much difference, but you can also bring that down further. I go to LOD 2 here, go to reduction settings, I can change the percentage, so it's gone down to 25%. I can bring it way down to like 10% if I wanted to. Okay, and then apply the changes. and you can see like what difference that makes. And if it's too destructive, you're like, okay, no, we'll put it back up. You can do. Yeah. And see, not much difference. So little changes like that can make a big difference. And you also got things like screen size you can mess about with. So the screen size is set to automatic, so it's grayed out at the moment. But that is at 0.2. So basically, when this thing takes up 20% of the screen, that's when it'll switch to that LOD. I can change that if I want me to. I can go down to auto compute LOD distances, turn that off. And then up here, I can change the LOD screen size. So I can make that now kick in at, say, 0.1, 0.6, whatever I like. And I can change when the LOD kicks in. And that's especially important for big vehicles, big assets that you can see. Little assets you can probably get down to way down. Okay. Is there a magic number for how many LOD levels there should be? No, not really. Would you use LODs as well as or instead of using nanite meshes? It'll be used instead of nanite meshes. So nanite meshes don't use the LOD system. They have their own thing going on. So if you're using nanite, you can just enable nanite and be okay. Now, bear in mind, nanite is not the one tick solution box that you want to worry about. Okay, nanite is only really noticeably effective when a model is super high resolution. If it's a normal model like one of these, it's actually going to be worse off because nanite takes longer to load up. So than a low resolution model does. But obviously, if it's super high resolution, then you got it's actually quicker. So it fits like in a middle ground sort of area. So there's a threshold you're going to eventually hit where nanite's actually going to be beneficial. But for most part, most of these assets you're going to get, game assets, you won't need to use nanite. So don't just use nanite on everything. That's not going to be the answer. You can do, but it's going to be slower. But on the load, not during the game. I'm not too familiar with what they've changed in 5.4's virtual texture pools. I need to have a look at myself. Okay, next thing about models. Now, one thing I've seen people do, especially who are making their own models, is they'll make their whole models. Like, imagine this whole block here. They'll model the whole thing in Blender, bring it into Unreal. Don't do that. Modular pieces. You want to make your models all modular. The reason being is that the way the renderer is doing the job is it's only rendering what it can see. So if it can't see it, it's not going to render it. Now, this is great when it's modular pieces because when it's modular, we're seeing tiny pieces of it and therefore easy to cut out the bits we don't see. But let's take a theoretical example. Let's say we're making New York City and we've got the Empire State Building as one mesh, just one big mesh. And I'm swinging through it as Spider-Man, and I can see 1 pixel of the Empire State Building. The engine will now render the whole building, textures and all, regardless of the fact that I can only see 1 pixel of it. Otherwise, if I see only 1 pixel of like the corner concrete pillar of it, it will only render that concrete pillar. And you can see this working in action. If you just like point your camera at anything, and oh wait, you have to push play, sorry. You can only do it in play. Or not. Where did it put me? Just play from here. There you go. So if I just face the camera this way and go to freeze rendering, if I turn around now, you'll see it's not rendering anything now. Only rendering what it can see. I can still walk around it. And you'll notice the collision is still working effective. So if I walk backwards, it's not going to be a problem. But you can see here, it's just cutting out bits that we don't have to worry about. So this solves a lot of problems because it don't have to render all these crazy models and textures that it doesn't need to worry about. It only needs to worry about this one point of view. Yeah. Okay. So when if you are making your own models, think modular, think Lego, make it in Lego pieces. The more modular it is, the better time you're going to have. It also is a lot easier to edit the level. So if I wanted to change what this building looked like slightly, maybe I want this a pipe here to be a little bit higher. I don't have to take the whole model back into Blender, edit that one little bit, bring it back in. I just need to move it in pieces here. So it gives you a lot more freedom in the game as well. Okay. That's right, Nanite does not support freeze rendering. Nanite's always rendering what it can see. But I say it's just a demonstrative tool. It doesn't actually do anything for you. It's just there to show you what it does. Okay. Okay. The next question is next topic we're going to go through is sound. Nice quick one, this one. So in sound, I don't think we're going to have any examples in here. Let's have a look. Yeah. Oh, here we go. Here's some good examples. So this is in the starter content. There is no reason to have, unless you're doing, hang on, let me rephrase that. If you're doing a 2D sound, i.e. sound that's in your playing like in a UI type thing, like music, for example, stereo tracks could be argued for. You could have them. The majority of all your sound effects, though, should be mono. So make sure these are all mono. This is a mono. The only ones that aren't mono here are the wind and the starter music and the starter birds. So ambient noises and music. And I'm guessing what they've done with the ambient noises is they're going to make it played in 2D. So that's what they're expecting it. But that's only if you want it played in 2D. If you want it played in the world, mono. Because the moment you go stereo, it doubles the space. So, yeah, don't do it. Yeah. Very easily done, because if you're recording your own stuff in Audacity, for example, that could be very easily done by accident. So yeah, just delete the track or merge it rather into one thing. Yeah, but big one there. And you can also write about the quality of the tracks as well. Like you see your sample rate here is a 44.1. You mostly want to keep that the same. I'll point to the screen, but you can't really see it. But it's a little stat there saying sample rate. 44.1 is CD quality sound. So most of the time you'll be using that. But let's say you're doing a little 16-bit looking game. You want it to make it look all and feel old retro sound. Just take the audio into Audacity or whatever and change the sample rate down to something a lot smaller. Not only will we optimize the sound file to be smaller in size, but also give that retro sort of sound as well. Yeah. Should we still use sound wave sound cues or the new meta sounds instead? Up to you. Meta sounds does have some really useful features in it, which does making complex sound systems a lot simpler. We've used them in Mimic, but we also use traditional sound wave sound cues as well. But yeah. And right, so you have a value ratio for this switch over from mono, stereo, or surround. Well, the surround thing is going to be handled for you based upon the spatialization of the tracks. So, for example, this collapse here, if I open this up. Down here somewhere. Attenuation settings. Oh, I haven't given it any. Damn it. Go. No. Okay. Great. Well, wait. Let me just drag it into the scene. You can see it. So if I drag it into the scene here, on the right hand side, if I go down to spatialization, it's turned on. That basically means surround sound. It'll play through whichever ear is closest to it, or surround sound system is close to it. But yeah, it will handle that for you. Anyway, that's basically sound. There's not much to it. Pretty simple. Lighting. If you're making a game and you don't need it, turn off Lumen. Lumen is a massive hog on resources. turn it off. If you're making a game, turn it off. Unless you need real-time dynamic lighting because you're doing like a crazy night and day system with all this crazy stuff, you just turn it off and use baked lighting instead. You're going to have a far much better time. So that's right, Timmy Jim. Yeah, noises are mono in real life. That's right. So the back to Lumen. So Mimic, for example, we had Lumen originally. I turned off Lumen and baked lighting instead. It doubled my frame rate. So consider it, and it looks no different because we had basically static lighting. It's not going to be moving. And with regards to lighting, once you are going to baked lighting, consider what needs to be static versus stationary, or what needs to be movable. These, for example, do not need to be movable. They've been turned on to movable. But granted, they've got Lumen turned on, so it doesn't really matter. But if you're baking it, you'll want to make this static. Okay? Unless you need it to be changeable, like turned off and on, change colour of it or whatever, or move it, then you change it to stationary or movable. If you want to know more details about the difference between static, stationary, and movable, I've got a video about that on the channel somewhere. Go have a look. But baked lighting is where you are. Now, to change it into non-lumen is a bit of a pain. It's not like a simple toggle. You basically have to turn off various settings. And what you can also do it by post-process volume too as well. You don't have to do it through the project settings, but, you know. So, go to Global Illumination, and you'll see down there, Dynamic Global Illumination Method, Lumen. You're going to change that to use the none. Yeah. And you can do that. Next up is the shadow maps. So you have to go to shadow maps. And by default, it'll give you virtual shadow map as the default setting. Change that to just normal shadow maps, not virtual ones. Okay. Next, to be able to bake things into your scene, you need to go to your world settings. And you have to turn off a setting in here, and I can't remember what I call it now. No, what do I call it? Light. Yeah. So, oh, yeah, sweet, turn off. If you want to make sure this force no pre-computed lighting is turned off. Is it off? I can't remember which way around it now. It goes force no pre-computed lighting. So pre-computed means baked. Where would the force light maps and other pre-computed light not to be created even when the engine thinks they are needed? Yeah, just to make sure it's turned off. And then you can bake the lighting. And to bake the lighting, you can go to build lighting only. But then, a good thing to do as well is something else. There's another setting you have to do. I think I've missed something out. Because there's usually something else here. And they usually have to restart this engine. Let me go back to plug-in thing here. Just search the word Lumen and just turn it off anywhere it has it. Reflection method, definitely turn it off for that. You can just use screen space for most reflections. And what screen space does, it's going to look at what the screen's rendering and reflect the reflection of the screen back out. Works well for like puddles and things like that. Yeah, you can get away with quite a few things like that. Screen space be fine for that. Software detailed, we don't know about it, we're not using higher Lumen. Usually you have to turn it off and on. Build. There usually is a light mass option here. Unless they've changed it, just kept it all into build lighting only. Whatever. Once it does it, it'll go through. Yeah, you have to allow it. Yeah. Baking lighting could be an issue with UV overlapping. It could well be, yeah. So one issue you have with baked lighting is the light maps. So light maps, if they're not generated properly, could have overlapping UVs and not bake correctly. You can easily fix that in modeling mode, but it generally automatically generates these light maps quite well when you import these things in. When you import a model in, there's a tick box that says generate light map. Turn that on. But yeah. Okay. How to do dynamic shadows on bait lighting props like doors, movable boxes, and barrels? You can't. Yeah. You want to make sure you want to use movable lights for those sort of things. The shadow, if something's been turned, if something's been told to be movable because it's been moved around in the scene, it won't bake its shadow. It's only going to bake its shadow if it's told to be a static mesh that's going to be completely static and not move around. So if you've got a door, for example, and it's going to animate open, take it to be movable and it won't bake the shadow in. The shadow will still be dynamic. Yeah, and we're now hitting like 100 FPS. We were sitting at about 70 FPS for this tiny little scene. Yeah, and we're down to milliseconds as well, to 10. Spikes up a little bit for some reason, don't know what, but yeah, there you go. But yeah, so the last thing I want to look at is coding. And this one's a good one, because I always get questions about this, and I always see people giving out bad advice or talking nonsense. But let's talk about some coding optimization. First of all, if your game has got low FPS, high millisecond counts, high VRAM usage, whatever, you'll find that most of your optimization for your game is going to be done graphical reasons, not code reasons. I say 95% of the optimization you'll be doing is going to be graphical stuff, not code. And that's because computers are generally quite good at doing code things. They're not very good at rendering things in real time. So I often see people go like, oh, if I use this bit of code, this node instead of this node, will it make my game run faster? And obviously everyone responds going, no, it won't make a damn difference. And they're right, because it isn't going to make a damn difference. The thing you're going to notice most is going to be graphical stuff. So code-wise, don't worry. There isn't much to optimize in code. But optimization is more than just making the game run better. It's also about making you run better as a designer. And when we say optimizing code, for the most part, what I mean when I say optimize code is I'm saying optimize code for it to work better for you. So you don't have to keep writing the same code out over and over and over again. This is when you want to use functions. This is when you want to use macros and function libraries, interfaces, all these sort of things. It's all about making it easier for you. Okay, so when we say optimize for coding, for the most part, it means optimizing for you, the creator. Game-wise, it's not going to make much of an impact whatsoever. It's going to make your life a little bit nicer. But there are a couple of things to be aware of in code that I will make you aware of. So one, let's go to the player character. Hold on. So, and these are very, very much, I think I see it mentioned as a comment or question on Reddit every single day. So, first of all, are tick events. Should you use a tick event? And like everything else in game design and game development, the answer is it depends. If you need something to be calculated on every frame, you need a tick event. So if you need to lerp something, you need a tick event. If you need to constantly check for something, tick event. Event tick is going to be running anyway, unless you turn it off. You can turn it off if you want. But for the most part, it's running anyway. And anything you do on here is not going to be that expensive. The things you want to avoid putting on tick are recursive functions. So these are functions that call themselves over and over again. So these are things like while loops and for and like if this, then call itself again and again and again and again and again and again, like a loop like that. You want to avoid recursive loops like that. That's not good. You don't want to use delays. That's not good. And you also want to avoid doing anything that requires anything that's heavy searching thing. So, for example, get all actors of class, and if I chose actor, for example, that's expensive, relatively expensive, because what it has to do is it has to get every single member and it has to go through every what we call buckets and look for each bucket and look for those actors, and it outputs them as an array. Very bad way of doing that. Better way of doing that is to put this on a begin play, or whatever event you want to make it trigger, and then promote that to a variable. Because once you've got it saved, that's it. It's saved. You don't have to search for those things anymore. They exist, and then your tick, you can then use these however you want. Yeah. So avoid doing things like get all actors of class on tick. Avoid doing things like cast as well, which brings me to my next point when optimizing casting. So a common thing we see is people doing something like this: get game mode, cast to first person game mode. They'll do that on like a tick event, for example, or on a movement input event, or whatever it may be. Now, what casting actually is doing is it's taking a parent reference, in this case game mode, and it's going to check to see if it can be changed to its child version of first person game mode. If it can successfully, great. It'll transform the reference pin over to that. And this is for our benefit only, because we need to be able to access those sort of classes and be able to call those classes. And so the casting here needs to handle that. Now, the thing we're going to notice here with get game mode especially is the game mode doesn't change mid-game. It is the game mode. So what you can do is just put that onto, again, like a begin play, for example, and promote it to a variable. Done. And now I can access it whenever I like. This does not equal doing this over and over again. This is a stored reference to that thing. Imagine if I'm having to guess a phone number, for example. Once I've got the phone number, I want to make sure I write it down. That's what that's doing. Yeah, it's writing down that phone number. It's the address of the object. And then we can access it and do what we want with it. So they're the two main things to look out for when doing code. But for the most part, when you're optimizing your game, you're going to find the most success with optimization is going to come from the rendering side of things, not the code side of things. Optimizing code is more about making life easier for you, the designer, not making your game run faster. Okay? Yeah, Prime, that's it. It's exactly it. It's a converter. It converts the reference over to a child reference. Okay. Oh yeah, I forgot one thing. Oh yeah, a couple of things as well. I'll go a few more things about coding wise. So as I say, most of the time you're optimizing it for yourself, the designer, to make life easier for you. But there are a couple of things you can also do if you really, really want to. So tick is basically every single frame of the game. One thing to be aware of tick is because it's every frame of the game, that means it's frame dependent. So if you've got a low frame rate, it's going to be acting differently based upon a higher frame rate. So this is where you see in some games, especially older ones, they're just too hard to play because the computers that are running them now are far more advanced and they're running at super high speeds, and it's just impossible to play. So yeah, don't do anything that requires sort of calculation stuff to be like on tick. Secondly, you can also turn the tick off. So when you go to class defaults, you can just turn off tick somewhere. There you go, start with tick enabled, turn it off. You can also use a timer, or you can just change the tick interval. So if you want to change the frequency to not be a per frame thing, but rather a seconds thing, you can just change this. So I've seen some people do like timers and do like a tick based timer. You just change this to be a timer. You can make that your built-in timer basically. So I can make this run at every 0.1 seconds, and that'll save me a lot already. Yeah, super easy way of doing that. You don't have to do a timer, but you can do that instead, and you can also change that during game as well. Tick interval, so you can also change it mid game if you like. So you sort of disable tick mid-game as well. You can change that mid-game as well. So if you want to turn things off when you're finished with them. So let's say a character dies and they're just going to lie on the floor now. Just turn off their tick. You know, they're just lying there. Turn them off. Yeah. So very easy wins if you want to optimize code somewhat. But as I said, you're barely going to notice any issues with that. Yeah. Next tool is one thing I forgot to mention is collision stuff. And I actually imported some things to actually prove this out as well. So this scene I've got here, generally speaking, actually, it's not too bad collision-wise. So collisions, you want to be aware of. Let's go into here. So let's take a look at this guy. So if I want to preview what the collision mesh is like for this guy, I can go to show, simple collision. And you can see here this green box around it, okay? That's the simple collision. If I go show complex collision, that's basically showing the wireframe of the model. And if I go to the collision settings on the right here, you'll see the collision complexity is set to project default, which is to use the simple collision. But you can change that to using the complex and simple or just complex if you want. Be very wary of this. If you use complex collision, that's going to increase a lot of problems, especially if you've got physics enabled in your game and you've got physics stuff bouncing into stuff and your character walking into it. Complex collision means it's got to do more calculations to work out how it's going to react to the physics engine. So where you possibly can, you want to use the project default for most things. There'll be some exceptions, but for that. And for whatever you do, do not, and I swear this again, do not turn on collision complexity to complex collision for nanite objects. That is one surefire way to make sure your game crashes straight away. Project crashes, rather. So don't do it. Just leave it at project default. And for nanite, you can just generate your own meshes. So you can go into collision here and you can generate your own simple collision. So this one here is pretty simple. It may not actually need it to be this simple. Simpler. You can make it simpler. Go to collision. You can do remove collision. I'm going to turn off the complex one. And I can just do add box. And it'll add a bounding box for me. I can always rescale this as well if I want. If I want to bring it in tighter or, you know, whatever I want. You can add multiple boxes to it. So if you want to add like I want to do one for this, but I want this ramp here to be important for the player. I'll just go to collision, add a box again. Turn that off. So like that. So I wanted to make sure the player had a ramp to run up. I could do something like this to make it stand out, that they can run up that sort of ramp, you know. So yeah, you can do that. But yeah, collision is very important, especially if you've got physics in your game. So I've got an example of some bad ones. If I can remember which ones they are. I think this is one of them. Yeah, so this thing here. If I go... Oh, and you can still see what collisions are good and what ones aren't good. If you go to lit mode, change it to player collision. You can see the collision. You can see like the difference between that and this. Yeah. There's no ever reason I need it to be that accurate with the collision profile of this. Yeah. Very expensive to calculate any collisions with that. So what I'm going to do is I'll go into the mesh. And if I go to show simple collision, you can see it like that. Which is, but collision, complex collision, as you can see, is all being lit up. If I go down to the collision settings, you'll see here it's set to use complex collision. Now, if I only want the player to walk around and not bump into that, I can just use the project default. But the problem with that is you've got these big gaps in the middle, where if I want the player to jump, I would want them to jump through that sort of gap there. So what I would probably do in this case is I'd add my own collision boxes to this. So I'd do one for the bottom. Like that. And duplicate it with Alt key. And I'll put it up the top there. That'll do. And I'll duplicate this again. Good thing about collision boxes is they don't have to be super accurate, because the player is not going to notice anything like weird, because they've got a big collision box themselves. So something like that would be fine. Yeah. Save that. And now we've got a much simpler collision box. I'll play the game. We've got this little lamp I can run up on. We've got our car can run up on this slope thing here. Much nicer. Okay. Yeah, Big Bowl. A game with crazy hitboxes is like Hunt Showdown, where the bullets can be able to shoot through tiny cracks in the farmhouse and whatnot to hit. That is handled like this. So for main collision, they would use the simple collision for everything. Okay, but if I want to be able to shoot through it, so let's say, for example, let's say like I was shooting through this, I want to be able to shoot through like the individual little gaps through here. On the player character, when I'm doing the shooting part, you'll do a line trace, for example. This is where you want to tick on trace complex. So for shooting games, turn that on, because you want to be able to shoot through the complex collision. So use that instead. So if you're doing a hit trace, use this, and that will allow you to shoot through cracks in the model, and even through like the rungs of a ladder, for example. Or through like little gaps through here. Just turn on that complex there to enable that usage. Okay. Okay. Now, as I said, this is just one short stream. Basically, we didn't even touch upon like the profiler and how to use that. We haven't even touched on multiplayer stuff and how to handle networking. I'm probably going to do a networking one as a separate video. We'll do another live stream about network optimization stuff, as that probably be a very different sort of beast. And we'll probably do a different video then again for the profiler and how to look at that and how to use that. But yeah, a few more things to go down the road there. But hopefully out of today you've learned something about optimizing your game, and these are very quick wins. From just doing very simple texture changes, we managed to get our VRAM down from using 2.2 gigabytes or whatever it was down to less than 1 gigabyte in VRAM. Yeah, so we made it super optimal, and as you see, the level looks exactly the damn same. No damn difference whatsoever. So those are easy wins. And as I said, when it comes to optimization, do it at the end of a project or near the end, and don't fret about the coding optimization. Most of the optimization you're going to notice and get most benefit from is going to be the rendering side of things. Computers are good at maths. They're bad at rendering in real time. So be aware of that. And in terms of Nanite, make sure that Nanite is not enabled for everything, because it doesn't need to be enabled for everything. And in fact, it's worse off the lower the resolution the model actually is. It works better for higher resolution models. So things that are photogrammetry scanned are really good for it, for example. But yeah, thank you very much, everyone. Hopefully you enjoyed it and learned something from it. I've had good fun. Once again, thank you for the support over the past week. It's been a crazy week. And thank you to everyone who's wishlisted Mimic. If you have yet to wishlist it, please go over to Steam right now and wishlist the game. Check out the trailer, share that to everyone, share it to all your friends, get them to wishlist the game. It really does help out a massive amount. So thank you again so much for those who have. And again, thank you to those who will be doing it after this live stream. Thanks again, everyone. Thanks for watching. If you want to support the channel and support what I'm doing here, head over to patreon.com/Ryan Laley. You can find all my videos early for just $1 a month, as well as many other benefits too. We've got a full go-kart racing series starting up on there. Done several of those. Recorded some more survival videos. They're coming soon to the Patreon. Widget stuff. Yeah, loads of stuff going up. But things are looking good. And I've got some cool stuff to announce about Mimic going soon. For those who are part of the Mimic beta test, we're going to go into Mimic beta test session in about 20 minutes. So in 20 minutes time, if you're in the Mimic beta, head over to the beta test channel, and we're going to load up Mimic and have a play test and check out the new changes that have been made. But yeah, thank you very much everyone. Take care, have a good night, and yeah, I'll see you next time. Bye bye.